In order to learn about how to send data back and forth between the Arduino and a processing sketch, I need to learn a little bit more about the serial port functionality in processing. And so to do that, I'm going to go to this processing reference page, but the serial port functionality is actually a library in processing. So I go over here to libraries. I'm going to click on that and I can find the serial library here. And this is going to give me the information I need in order to set up a serial port in a processing sketch. And so if I click on this serial object right here, I get an example of how I'm going to use this code. I'm going to import this processing.serial. That's basically importing the processing library. So now I have serial objects and I have the functions that are specific to those serial objects. I can look at a list of serial ports, then I can assign my port that I'm going to use in my processing sketch to a new serial object that is one of those ports, and I set the baud rate, and then I can do things like write and read from that port. So let's go ahead and do that in a sketch. I'm going to import my processing.serial library, and I am going to declare a variable of type serial I'm going to call my port. And then I'm going to, if I go back to this, I'm going to do that print array command here in setup. So I'm going to print array, and print array is a generic processing command actually. It's not a serial port specific command. It's a generic command to print a full array of values. And in this case, my array is going to be what I return from this serial list function. So if I go back to the serial port documentation, I go to all of the functions that are available to me. List is one of them. And what I can see is it's going to provide an array. It's going to return an array of strings. That is the return value from that function. So if I go back here, I can print that array of serial ports. So I'm going to do serial.list, and that will return my array of serial ports. Print array will print that to my console window. So if I run this, and I make my console window a little larger, I see a lot of different ports here. So one of the tricks in using the serial port in your code is figuring out which one of these your Arduino is on. And a really easy way to do that is actually go to your Arduino and see which Arduino you've been able to communicate, which port you've been able to communicate to your Arduino on. In this case, devcu.usb modem. But it might look differently if you have a different software environment. So I see that that is port 1 here. So port 1 is the one I'm going to use from here on out. So this is always a useful chunk of code to have in processing to automatically figure out what port you're going to be on. Once you're on that port, you actually want to assign my port to a new serial object. And the syntax of this is a little confusing. So what this line is doing is it's assigning my port, which is of type serial, to a new serial object. And that would lead us down a very big rabbit hole in object-oriented programming. Let's say it's a new instance of a serial port. And the syntax of this is the first argument to that is going to take the kind of parent program of the parent sketch, which in this case I'm just referring to as this. The next one is going to be the string referring to my serial port name. And so I get that from serial list. It's an array, remember, and so I'm going to index, use the index 1 to access the one that refers to the port that my Arduino is connected to. And then I provide the baud rate that I want to talk over. So I want to set this to 9600 baud. Once I've declared my new serial object, the first function I'm going to do is clear the buffer. Right? So this .clear function is what's clearing the buffer. And the buffer for a serial port, imagine a lot of bits coming in over the serial port and they all queue up until I read them, and that pulls them out of that buffer or that queue. And clear is just going to start me from scratch. I'm getting rid of anything that's already in that serial buffer. So now I've initialized my serial port. In the draw loop, I want to continually check that serial port to see if new information that's useful to me has come in. Right? And so the first thing I'm going to do is to see if there is data available in the serial port. So I can see an example of this content of this particular function here. So in the draw loop, I'm using a while loop here. So while my port available is greater than 0, so available here is returning the number of bytes in that buffer. So once I have bytes in my buffer, I'll go into this while loop and I can read those bytes. I'm going to use that same syntax. So while my port available is greater than 0, and I'll include my close curly brackets, I'm actually going to do something in reading that port. I've added a function to read data from the serial port. In this case, it's a little specialized. So I declare a string variable called serial import, and I'm assigning that to whatever I'm able to read from my serial port until I get a new line character. So this read string until is a really useful function in my processing serial library that gives me all of the characters in my serial buffer up until that new line. And what I'm going to do after that is print what I got as my serial input, so I get some sense of what I'm seeing on my serial port. Now to get actual data on my serial port for processing to read, I'm going to program my Arduino with a simple hello world. So I begin the serial port at 9600 baud, I print line, so I have that new line character at the end of this, and I print hello world every second. If I upload this to my Arduino and I look at this over my serial monitor, then I'm going to see hello world continually popping up. And this is what I'll hope to see in processing as well. So I'm going to close the serial port because they both can't access the port at the same time, and go back to my processing code and try to run this. So one of the things you see here is I'm getting all of these nulls, right? I do see my hello world pop up, but then I'll get a bunch of nulls again, but then hello world will pop up every second again. So these nulls are just random bits and stuff that are showing up on the serial port, and I'm going to have to filter this so I'm not, trying to interpret data from these nulls as I go forward. So to do that, I'm going to check if my serial input variable is equal to null, or is not equal to null, and then if it is not equal to null, I'll print my string there instead. Okay, so I'm still waiting until I have some bytes available on my serial port. I assign my serial input string to what I read on that serial port until I get a new line character. And now I'm filtering all of those inputs. So if I'm not equal to null, if I'm equal to null, I just ignore everything. If I'm not equal to null, I'm going to print my input. So I can run this and I should just get hello world showing up now. Right? And one thing that you'll discover as you do labs and do more things in processing with the serial port is that you actually have some problems with some extra spaces being added, and this often just depends on the operating system that you're in. So something that we will use very heavily is the trim command. So this is a string command that you can look up in general processing that's going to trim any extra white space characters before or after the string. So I can rerun this and I should still get those same hello world popping up, but you can see now I'm printing it on every line. I don't have additional kind of new line characters and carriage returns in there. I can also send data over my serial port from processing to my Arduino. And in order to do a little program to demonstrate this, I'm also going to use some keyboard input for this. So if I go back to my processing reference and under keyboard, I can see I have a lot of different things. But really what I'm primarily going to be using is this key pressed variable, which is a reserved variable that will be true if I'm actually pressing a key on my keyboard. And if I am pressing that key on the keyboard, this other reserved variable key will be assigned whatever key I'm pressing. So if I'm pressing an E, I'll see an E character in key. If I'm pressing an M, I'll see an M character in key. So I'm going to keep the bulk of the code in setup, where I create my new serial port, I clear that buffer. But now in draw, I'm going to check if key pressed is equal to true. Then I want to print something to my console so I know what I'm seeing there. So I'm just going to print line that key variable. You can see it shows up in pink, so it's a reserved variable here. And so this just is going to help me make sure that the key pressed bit is working correctly. So it's always good to kind of start off in small increments. So if I press E, I see some E's there. N's, I see M's. M, I see M's. E's, I see E's. 3's, 5's, 1's. So I can see all the characters that I'm pressing on my keyboard with this key command. So what I want to do now is take that key variable and send that key character and send that over the serial port to my Arduino. To do that, I'm going to use the write function in the serial library, and I can write any variable over my serial port. I can write bytes, characters, ints, arrays of bytes or strings to that serial port. In my case, I'm just going to send that one character, which is a byte, represented by the key that I pressed to my Arduino. So in my code, I add myPort.write, and I send that key variable to that write function, so that should send it over the serial port. I'm actually going to delay a bit so I don't send 50 ones because I hold down the 1 button a little bit too long. So to actually do something with data that I receive on my Arduino, I'm going to write a new Arduino sketch. And in this case, I am going to declare an incoming character variable that I initialize to 0. I start my serial port, and I have that same available function that I did in processing in the serial library on the Arduino. So I'm checking to see if I have bytes available on my serial port. I'm going to read those bytes, and this can be a little more complex if you have a lot of bytes, if you're sending a string. But in this case, I'm sending 1 byte. I assign that byte to my incoming character, and if that incoming character is an E, I'm going to turn on an LED for a second and then turn it off. So if I upload this and then run my processing code, I have my Arduino that has this LED right here. This top one is connected to pin 3. And in my serial port, I'm just waiting for a key to be pressed. So if I press G, nothing happens. J, nothing happens. W, nothing happens. And E, the LED turns on. So that gives you some sense of how I can send data from processing to the Arduino as well. And this would be really useful for controlling some kind of system that your Arduino is embedded into.